Okay. How's everyone feeling today?
Totally awesome, sir.
So, lesson one, the question is, what is the hidden relationship between kinetic energy and work? And of course, in order to answer this question, we first need to define what kinetic energy is. We first need to state how to calculate work, and then we can talk about the hidden relationship between the two of them. So, kinetic energy is the energy of motion. Anytime an object is moving, it has kinetic energy. If you want to calculate the kinetic energy of an object, the hidden relationship turns out to be 1/2 times the mass of the object times the velocity of the object squared. We're not deriving this formula. We actually derive it in physics C using calculus. So here we're just taking it as a defined quantity. The kinetic energy of an object is just 1/2 times the mass times the velocity squared. Work is done when a force acts on an object and changes the object's kinetic energy. If you want to calculate work, what you have to do is take the component of the force and multiply it by the direction that the object is moving. For example, you have an object, you have a force, this is theta, and the object moves forward, displacement x. In order to calculate the work done would equal the x component of the force multiplied by the forward displacement. Now, that x component of the force would be this leg right here, f sub x, as opposed to the y component of the force, f sub y. We want that x component, the component of the force that's in the direction that the object is moving. And if we look at the little trig SOHCAHTOA, it turns out that f sub x is equal to the whole force times cosine of theta. So if we make that substitution in here for f of x, we get the general formula for work. Work is equal to the force times the cosine of theta. That there gives you the x component of the force times the forward displacement. Generally, though, the parentheses are dropped and the cosine theta is brought all the way to the right. So the general formula for work is the force times the forward displacement times cosine of theta. Where theta is the angle between the force and the forward displacement. And those little arrows above that just indicates vector quantities. So now that we define kinetic energy as 1/2 mv squared, and we talked about how to calculate work, the The answer to the question, what is the hidden relationship between kinetic energy and work, is as follows. If you take the work done by all the forces acting on an object, add them up, that gives you the total work. Well, the total work always equals the change in kinetic energy of the object. This is known as the work energy theorem. It could be blown out on the right-hand side. We could say the work total equals the final kinetic energy minus the initial kinetic energy. Same equation. And then we could blow out the right-hand side even more, and we could say that the total work equals 1/2 mvf squared minus 1/2 mvi squared. And that's lesson 1.